Today we'll discuss about the fulladder using a verilog HDL data flow modeling. So first you open the Xilinx project navigator. Okay, here already we have created the folder and you can choose your folder. So you can create a file, source file for the fulladder. So here, so now sometimes if there is any garbage, you go to file and close the project. Okay, so then file, open the project, so what are the combinational circuits are developed, all the files will be displayed here. Combinational circuit, so half-VL already we have designed. Now today we'll discuss about the fulladder. Okay, so right click on that, new source, create a new source file under the project name combinational circuits. Double click on that verilog model, so fulladder FA underscore DF data flow modeling. Next, so skip the port names, will declare all the ports in the coding window. Then the source name, file model name, see I'm giving same name in order to avoid the confusion. Then finish. So the coding window is editable, so edit window or coding window, so you can edit the coding window. So double slash command line. So today we are going to design fulladder using verilog HDL. Okay, data flow modeling. So the modeling is data flow modeling style using the keyword assign. Okay, so if you want to use data flow modeling, remember that you have to use the keyword assign. So it's a double slash for single line command. Now we'll define the ports. So here the first video I given all the commands in detail. Now we'll concentrate on the program. So fulladder, what are the specify the port list. So single bit fulladder, we are going to design a single bit fulladder. Design single bit fulladder. So what are the port list? Sum, comma C, comma the output ports. Specify the output ports first, followed by the input ports A, comma B, comma C in. So the double slash. So I have the habit to give the commands for each and every module. So here specify the input and output ports. Okay, so module name, module is a keyword, module name. So this is module name we are only choosing for understanding purpose, fulladder underscore data flow modeling. Okay, and followed by open the bracket, the declare the outputs first, followed by the inputs, end with the semicolon. So follow the syntax properly. If you do any mistakes in the syntax, then it will show errors in the console window. Next step, declaration of the ports. Out of the IO ports, the output ports are S and C. So the keyword output, the outputs are sum, comma carry, end with the semicolon. Okay, then the syntax, you can give the commands line. So declaration of the ports, declaration of input and declaration of output ports, declaration of output ports. Here we are using single bit, so scalar means single bit, single output. Okay, scalar, so it's a single output. you can declare output S comma C. Okay, the next inputs you declare input A comma B comma C in. Okay, so what is the command you can give here? Double slash for single line command. So declaration of input ports with the keyword input and specify the input ports A comma B comma C in. All are single, okay, single bit only, not multiple bits, single bit. Next one, we are going to model by, there is for data flow modeling, there is no wires inside the chip. We least bother about the inside the chip, how the gates are connected. Only data flow modeling, only black box and the IO port specifications, specify the ports and declare the ports. Then body of the program. So the body of the program data flow modeling. So using assign statement, assign. So assign S is equal to. So we know very well that the derivative, the equation, the Boolean expression you should know here. The Boolean expression for sum is equal to A, the exponent XOR operator exponent, B, the XOR operator exponent, and the third one terminal is C in. So what is the explanation I can understand here? So here the exponent operator, that is a verilog constructs the exponent operator, different operators. This is a unary operator. There are different operators: unary operators, binary operators, ternary operators, logical operators, relational operators, combination operators. So when you study the verilog HDL constructs, so you can be familiar with all the operators. So here I am using exponent operator for XOR operation. Okay, we are using the exponent operator. Exponent operator is, what is the exponent operator? The exponent symbol. This is the exponent symbol. This is the exponent operator for XOR operation. Then assign, okay, XOR operation. So assign sum is written, C is equal to, okay. So what is the equation? A and B. So and operator is there. So A and B, okay, or A and B plus symbol is or. So A and B. So in the operator there is a pipeline operator. So this is a pipeline operator for or symbol. A and B for the and symbol. This is the or symbol. So what is and B and C in, and the or is a pipeline operator, C in and A. Okay, so AB, so here I can give the explanation. Sorry, here in the double slash. So what is the C is carry equal to, so A, so you know A B, okay, plus AB plus B C in plus C AB plus B C in plus C in A. So this is a carry from the Boolean expression or the sum. So here you can write sum S is equal to, okay, sum equal to, what is that Boolean expression for full adder? A XOR B, okay, A XOR B XOR B XOR C in. So for this Boolean expression, we have written using data flow modeling by using the operator exponent operator. XOR symbol is the exponent operator. So for carry, we know the logical expression AB plus B C in plus C in A. So this equation, how to express using Verilog HDL language construct in data flow modeling, assign. So we are specifying the port C for carry. C is equal to AB. So A dot B products. Okay. So there is a AND symbol. So A and the operator is and is used for AB, or plus is or symbol. So for or, the pipeline operator we are using for or, and B and C in. So and operator B and C in. So these are sum of products. Okay. So this expression everyone should know from the full adder concept, truth table, and Boolean expression. In Boolean expression, the carry equation is AB, sum of the products AB plus B C in plus C in A. So the product is and operator. So sum is OR operator. So the OR operator is in the verilog HDL pipeline operator. Similarly, the product is AND operation for AND operator. Operation, this is the operator for OR function or pipeline operator, OR operator. So the pipeline symbol is used for OR, the AND symbol is used for, you can note on the AND symbol for product, okay, product and function, product for product and function, product and function and function. Similarly, the okay, you can go for multiple line comments also, star. Okay, multiple line comments I can write here. So carry, so and for product and function. Similarly, the pipeline operator or for, okay, sum, that is a or operator, or operator, or operator, or operator. So this is and operator. Using operator, we are writing the data flow modeling. And operator or operator. And operator for product function, the symbol is symbol, the ampersand sign. Symbol ampersand sign. Similarly, the symbol pipeline symbol for sum or sum for or operator. Okay, this is data flow modeling concept. So then the data flow modeling, you have to use the keyword assign. And what is the Boolean expression from the schematic and the truth table? What is the Boolean expression? The Boolean expression directly you can write by using operators in data flow modeling. So assign S equal to A XOR B XOR C in, and assign C is equal to A and B, or B and C in, or C in and A. So different styles you can in the body of the program you can write. Then end model. Okay, simple program, full adder we written. This is a data flow modeling. Then you save the program. Save the program. So save, otherwise control S. End with the semicolon. End with the semicolon. End model. Then you choose the full adder program. Then save. Okay. Check syntax you do. Then you check syntax. Check syntax. So some errors. Unexpected token is equal to C. Okay. Line 6. Here also we forgot semicolon. So do some mistakes, no problem. Debug the programs. Okay. In the console window, expect some errors and how to debug the errors. Simply don't type as such. Okay. Coding efficiency will be improved only by debugging the program. So I'm also doing so many mistakes. A, B, C in end with semicolon. And assign statement end with a semicolon. Okay. Now I can check syntax. Do you want to save this file? Yes. Again one error. What is the error? Terminated command, line 12. Yeah, here we are not terminating, so it's compilation problem. See, it's a multiple line commands, no? So for single line command, double slash, okay. For multiple line commands, you have to start with a slash star and end with a star, slash. Then only this will not be compiled. Otherwise, without this, this also will be taken for the compilation. That time the error will be shown. So I am doing so many mistakes. So we can learn what are the errors we are getting. So now again check syntax. Now we'll see. I think hope yeah. See, check syntax succeeded. So in this coding window, follow the syntax error properly. It will not give any logical error. Only it will show the syntax error. So first time I have I missed to terminate with this semicolon some of the statements so that the error was shown. Similarly, second time also I got some error where I have noted that I forgot to terminate the multiple line comments with the star slash. Okay, like this you do some mistakes and debug your program, and finally you have to get the complete the compilation. So succeeded with the tick mark. Then you go for synthesis X. Synthesis you have to do. Synthesis is do. Then view synthesis report. So the synthesis report you can see all the in the console window. The synthesis reports can be generated. So what are the synthesis report? So here logic level synthesis, netlist, the area netlist file generated, and what are the device utilization summary, how many LUTs, how many slices have used in the Spartan device. So in the timing report, everything you can generate the reports. Then view RTL schematic gate level. So what are the inputs? A, B, C in sum and carry the outputs. You can double click on that. So the schematic will be generated. So double click on that. All the gate level netlist you can view. So this is your RTL schematic. This is your RTL schematic gate level implementation. Then you go to the program.v file. Okay, then you can do other automated steps, the place and route everything. So translate, double click on that. Then mapping, double click on that. Then place and route, double click on that. Okay, place and route. So all the synthesis flow automated tools will be done. So this is a simple fulladder program how to write a RTL schematic for the fulladder. So now we have written the code, we have checked the syntax, everything, and synthesis are also done. Next I will tell you how to write a test bench. Okay, how to write a test bench for the design, our design. So half adder, full adder. So everything I written the code. I have to test. I have to verify simulation and synthesis. So here the two words simulation and synthesis. These are the design flow, synthesis design flow. Okay, the backend process, placement, floor planning, placement, routing. Okay, how to implement, how the physical layout dumping into the device. Okay, Spartan device here. We have chosen the target devices Spartan 3. So that part we have done by using this tool. But the simulation part, okay, the simulation part, the functionality of the design you have to verify. What do you mean by simulation? By giving proper inputs. What are the three inputs A, B, C in? What are the possible combinations for the three inputs? Starting from 0, 3 inputs, no, so 2 power 3, 8 combinations can be given. The test vectors can be given as 8 inputs, 0, 0, 0, 1, 0, okay, 1, 1, 0 or triple 1. So all different possible test vectors can be given, and you can verify the functionality of the design, whether it performs or not, whether it works or not. That is called simulation. For the simulation in Verilog HDL, for the simulation also, Verilog test bench. So simulation, so you can do the simulation by writing the test bench code. So instead of forcing the signals for each and every input pin and validate the output, you can write a test bench in which you have to follow the Verilog HDL constructs and specify all the combinations of test vectors and verify the output. Okay, that we'll discuss in the next video. Okay, so in this video only we have written the code verilog HDL for full adder using data flow modeling we have written. So how to simulate by writing a test bench, okay, for the full adder, I'll post in the next video. Okay, thank you.